Yeah, I can go ahead, Ajay.
Hello, Professor. I'm Ajay. Along with me is my friend Sai Karthik. We collaborated uh, to complete our final project, Best Buy application, mainly focusing on Kubernetes. So, yeah, this is the basic architecture. These are all the services that we're able to develop: storefront, store admin, order service, product service, AI, and MongoDB. So as you can see, this is the basic architecture looks like. So this is where the customer interact through the application, through storefront, where they can able to see the products and yeah, different electronics, and yeah, they were able to order and through order service. Yeah, order queue is the one that manages all these orders. Whereas from the employee side, they will use store admin service to interact with the products and manage these products. And make line service is the uh, where all the logic happens to complete the order. And we're also introduced AI service like GPT-4 and Tally to help the employees to generate description and images for the products much easier. So this is how the architecture is going to look like. And in this project, we are able to create different Docker images. So to develop the Kubernetes services. So yeah, from here on, my friend will continue. Saikatik,
Right.
go ahead.
All right. Hello, Professor. Myself, Sai Karthik Kalidas. I'm along with Ajay Modla. We both coordinated together and we developed a Best Buy cloud native application. And as Ajay explained about the architecture diagram, this is pretty much similar to the architecture diagram what we did in Lab 8 in developing the Algonquin Pet Store on steroids. So the only difference here is that we removed RabbitMQ service and we replaced it with Azure Service Bus. That's the only major difference we did here, and also the storefront, the UI of the storefront. So basically, the Azure Service Bus, order database, and this large language model and the image generation model, these four services acts as a backing services to the Best Buy application. So and also we forked your repositories from Lab 8, and this is what we created for each microservices, right from storefront to MongoDB. And so these are the Docker images we built through the Docker file from each microservices, which was available in each microservices. And yeah, so so as you could see here, so these are the Kubernetes clusters, which is running right now. So we have all the service ready and up, and it is running right now. So here, as you could see from the workloads, so these are the deployments which we did using the all-in-one YAML file, and these are the respective pods for each microservices. And yeah, let's look into the storefront and store admin performance. So this is pretty much the storefront what we have for the Best Buy, and in store admin, so where we could add products and remove products from the admin perspective. So let's try to add a product here. So let's say let's add a Dell laptop. Dell laptop, its pricing, let's keep it like $800. And yeah, and unfortunately here we have some quota issues with the GPT-4 model. We were able to generate image, but we are not able to generate the description using the GPT-4 model. So that's specific to the quota issue. But still, let's try to create an image. So just give a moment. So let's take, for example, So these are the keywords to build up a, oops, sorry. No, 800. So let's list the keywords to make the GPT-4 to give the description of the product. But this won't work actually. We tried it several times, but this was not this specific GPT-4 model service. It's not working. So even we tried several troubleshooting steps, but still we are not able to make this AI service working. But we checked its port status. From the Kubernetes clusters, even for the AI service, it's it's running fine actually. It's the status it's showing running, but it's specific to the GPT-4 model where we're not able to get the description for the products from the keywords. So it takes some time. No, see, we got an error. But instead, if we are able to give the description directly, for example, let's take a sample description and yeah, let's try to change the model down. Oh, down S45. Okay. So when we try to generate an image, so this generating image, it is backing by the Dolly 3 model, which we integrated using Azure AI services. So yeah, pretty much good. We got an image for the description which we provided. So now let's try to save the product. Successfully saved. Good. So let's check the products. Was it okay? We have the products here, and also let's check in the storefront whether the product got updated. And yeah, we have this Dell laptop being added here. So yeah, so and also we have the Azure Bus services, which is from where we can see the request and messages here. And this was implemented into the order service and the make line services. And okay, so this is the all-in-one YAML file where we integrated all the microservices into a single file. The only changes we did, we changed the name of the image from the image what we developed from the using the Docker file from each microservices. And yeah, let's go to the building process, like how we built this uh, um, application. So for the first prerequisite is to install Kube Control. And once after installing Kube Control, you will be installing Azure CLI. So the main reason to install Azure CLI is to have a communication between your Azure portal and your Visual Studio Code. And the next one, we clone the repository, and then we create the AKS cluster. So these are the pretty much steps what we did in creating the AKS cluster. So in the node selection, we created one system node and one worker node. And yeah, so once the AKS cluster is created, so we connected to the Visual Studio Code using this credentials. And once after this, we went on creating the AI backing services, where we created Dolly 3 and GPT-4 model. And so once the deployment is done, what we did is we retrieved the primary key from the deployment, and we encoded using this base64 encode command. So and also once after doing this, you need to update your secret secret YAML file, which we have here, the secret YAML file. So in the place of open API key, so this is where you will encode the key and paste the encoded key here. And this secret key is for the service bus secrets, and this key is generated from the bus service. So here, when you go shared access policy, so we created one for the send request, and we copied the primary key and we encoded it. I mean, encoded and paste the key there, and one for the send request and one for the listen request. Yeah. So these are the two keys which we injected into this secret keys, and the next step would be like, yeah, and also you have to modify the environmental variables in your AI service deployment files. And once after doing this, we deployed Azure Service Bus. And once after this, and we went yeah, this is the process which I explained now. So we created two request key, one for send and one for listen. And so we integrate that specific key with the yeah. So so this is a command which we use to encode that specific key which we took from the bus service. And yeah, so this is the one which we integrate with order service using the Azure Bus Service, and the next one is for the make line service. So as you could see here from the uh, architecture diagram, so this bus service is connected to the order service as well as the make line service. And yeah, so once you once you updated your secret file, so you can push that secret.yaml file into your Kubernetes clusters using this following command, and you can also verify whether the secrets has been pushed. And once after deploying the secrets, let's deploy the entire app. So this is the YAML file where we have the uh, all the microservices are put together in a single YAML file. So where we have for order service, product service, AI service, make line service, and the other rest of the other service as well. And once this deployment is done, you can check for the running pods. And also we just showed you like how it is worked in the front end and in the store admin as well. So yeah, this is pretty much about developing the Best Buy cloud native application. And also while developing this specific application, we went into quite few issues actually. Obviously, without issues, there is no good results, right? So yeah, and also we tracked the issue what we had while deploying the microservices into the Kubernetes clusters. So regarding the errors, I would like Ajay to explain a bit more about it.
Thank you, Psychotic. So, Professor, we were able to overcome a major error during the project. So, yeah, so as you can see, when we are trying to integrate the all the microservices that we developed into a AKS cluster, so yeah, for some apps, as you microservices, as you can see, it says a crash loop backup. So, yeah, during the troubleshoot, we performed like logs for every pods to check, to understand what this error means. Like, so we were able to see like we thought like it might be the insufficient memory, like incorrect configuration, and yeah, and maybe dependencies errors. But yeah, what we understand is it's an architecture related error, as we used Mac to develop this whole project, which is ARM based. So, but the Kubernetes cluster is x86, which is a different architecture. So there is a compatibility issue between them. So what we identified as a solution is, so we want to rebuild the image, like the Docker images to make it compatible for both architectures. So yeah, that's the solution that we identified. So we started rebuilding all the Docker images. So first, we built the using buildx. We build the Docker container, which helps us to rebuild all these images in these architectures. Yeah. So these are all the commands we use: Docker buildx create Docker container. Yeah. So once we able to create these rebuild these images, we have to push this into Docker Hub and pull it again, which helped us to overcome this problem. So this is the major uh, problem we went through.
Yeah, exactly. Thanks, Ajay. So let me re-summarize the last issue what we had here, Professor. So just to troubleshoot the issue what we had with the compatibility issue, so we used a multi-platform build with Docker container drivers. So which means we are creating a Docker builder called Docker container, and using that specific builder, what we do is we are rebuilding the Docker images of each microservices which had the crash loop back off issue. So this is the command to rebuild the Docker images, and all we have to make sure is change your directory to that specific microservices which was affected, and use this using this command like which from buildx is which is using a new Docker builder, and and this one where it defines the build Docker image is compatible for both AMD 64 as well as ARM 64 architecture. And once the specific Docker image is built, it pushes the image to your Docker Hub repository. So once this is done, what you have to do is you have to push that specific Docker image to your local repository, and from there it get fetched by the all-in-one YAML file, and yeah, all the microservices which was deployed in the cloud in the Kubernetes cluster started to running. So yeah, this is the process we did here. So we can even show you here like how this was done. Uh, no, this is not the one. And yeah, so this one, yeah. So now here we are rebuilding the Docker image specific for product service. So in order to do that, you switch your directory to product service, and you run that Docker builder command, and this pushes that's the specific build to your Docker Hub repository. So once this is done, you can pull it back to your local. And for this specific image, it gets pulled to the all-in-one YAML file. And yeah, so by doing this, we were able to successfully make the pods in a running state from where we didn't see any crashback of issues. So this is pretty much all about the application we developed for the final assignment. And yeah, thank you so much, Ajay, for your coordination in this, and appreciate your work. Thank you. Thanks a lot. Thank you, Professor.
Thank you.